All right, welcome to this explainer. Today, we're going to equip you with a totally foolproof method to absolutely ace any binomial theorem question. You know, if you're prepping for your IGCSE or O-level math exams, you've probably looked at the binomial theorem and thought, wow, that looks incredibly intimidating. But I'm here to tell you a little secret. It's actually just a super predictable, totally repeatable pattern. By the time we wrap up here today, you won't just memorize the formula. You're going to be completely confident dismantling real high-level past paper questions. Let's get right into it.
So, here is our game plan. First, we'll officially meet the binomial theorem. Second, we'll dive right into our first expansion practice. Third, we'll learn how to hunt for targeted coefficients. And finally, number 4, we're going to tackle some advanced exam practice.
Now, I want you to really think about this for a second. Imagine you're sitting in your exam and you have to multiply out 15 sets of brackets. I mean, literally 1 plus x times 1 plus x times 1 plus x 15 whole times. If you try to do that manually, no way. You'd run out of time, you'd run out of paper, and honestly, you'd probably just give up right there. It is practically impossible to do under pressure.
Which brings us to section 1, meet the binomial theorem. So, what if you had a magic key to unlock any expansion without doing all that crazy manual multiplication? Well, here it is. This formula right here is about to become your absolute best friend. It lets you expand any two terms raised to a specific power, and it's actually pretty straightforward once you break it down. A is simply your first term inside the bracket. B is your second term, and n is the total power sitting on the outside of that bracket. That little r? That's our index. It's the piece that changes as we move from the first term of our answer to the last. So the big takeaway here is that you don't need to multiply brackets forever. You just follow this one simple recipe, n choose r times a to the power of n minus r times b to the power of r. And to keep things super clean and avoid those really frustrating, silly mistakes, we don't just write a massive, messy horizontal line of algebra. Instead, write the terms vertically and systematically plug your variables into the formula. You just start with r equals 0 for your very first term. Then r equals 1 for the second. Then r equals 2, and you just keep going. And as you do this, you're going to notice this really beautiful pattern emerge. The power on your a term will gradually decrease, while the power on your b term will gradually increase. It's like a perfectly balanced seesaw.
Moving right along to section 2, first expansion practice. Theory is great, right? But math is absolutely best learned by actually doing it. So let's put this into practice right now with a real-world scenario. Check out this actual challenge straight from a past exam paper. It's asking us to find, in ascending powers of x, the first 4 terms in the expansion of 1 plus x to the power of 15. Now notice the catch here. It only asks for the first 4 terms. We don't need to find all 16 possible terms. That would take forever. We literally just stop after we found the 4th one. Let's see how this builds exactly like we just talked about. Our n is 15, our a is 1, and our b is x. By mapping our r values from 0 up to 3, we generate exactly those first 4 terms they asked for. Take a look at that first line, where r is 0. 15 choose 0 is just 1. 1 to the power of 15 is 1, and x to the power of 0 is 1. So, your very first term is just 1. Easy, right? Then you move down to r equals 1. 15 choose 1 is 15, and x is to the power of 1, which leaves us with 15x. As you continue down to r equals 2 and 3, you'll literally watch the power of x naturally ascend, exactly like the question demanded. It's purely systematic. No guessing required. Oh, and here is a massive pro tip for the second part of that past paper challenge we just looked at. Notice it had a minus sign inside the bracket, like 2 minus 3x to the power of 10. Well, whenever you have a minus sign inside those brackets, your resulting terms will always alternate between positive and negative. It's a hard rule. It'll start positive, the next term is negative, then positive, then negative. Seriously, keep that little trick in your back pocket to quickly check your work when you're stressed out during the exam. All right, on to section 3, hunting targeted coefficients. So you've mastered the basic expansion. But what happens if the exam only asks for one single specific term hiding right in the middle of a massive equation? Let's level up a bit. I see students do this completely wrong all the time. A question asks for, say, the coefficient of x cubed, and they literally start expanding the entire binomial from r equals 0 all the way to the bitter end. Look, expanding the whole thing just to find one tiny term is a massive waste of precious exam time. We're not doing that. Instead, we're going to act like a sniper. We're going to hunt for exactly what we need and just completely ignore the rest. And your secret weapon for this is identifying the correct R value before you even touch the formula. The rule here is incredibly simple, guys. If your X variable is sitting in the second term of your binomial, which, let's be real, it is about 90% of the time, the value of R is simply the exact power of X you are looking for. It's that straightforward. If you want X cubed, R is 3. If you want X to the power of 5, R is 5. Boom. Direct hit.
Which brings us nicely to section 4, advanced exam practice.
Okay, it's time to test this advanced sniper concept against some genuinely tougher past paper challenges, just to really lock it in. Take a look at this one. We have a list of different expansions, and the prompt simply says, find the coefficient of X cubed. Let's focus on option B as an example, which is 1 plus X to the power of 5. Remember, we are absolutely not expanding the whole thing here. We apply our logic. We want X cubed, and our X is right there in the second term. Therefore, we instantly recognize that R equals 3. We take that and plug it directly into our formula. 5 choose 3 times our first term, 1 to the power of 2, times our second term, X to the power of 3. And we just completely ignore all those other irrelevant terms. You calculate that one single line. 5 choose 3 gives you 10. Since 1 squared is obviously just 1, your answer is 10x cubed. The coefficient, the actual number attached to the front of the X, is exactly 10. I mean, this just brilliantly illustrates how much time you save. Just like that, you totally bypass all the messy, unnecessary algebra and land directly on your hard-earned correct coefficient. It's a total game changer. All right, let's look at one final super high-level challenge. This is the exact kind of question examiners use to separate the top-tier students from everybody else. The question reads, the coefficients of X and X squared in the expansion of 2 plus AX to the power of 7 are equal. Find the value of the non-zero constant A. I know, it looks a little tricky at first glance, but trust me, we already have all the tools we need to crack this. So we are literally just going to use our targeted hunting method twice. First up, we hunt for the X term. Since we want X to the power of 1, we set R equals 1. Plugging that in gives us 7 choose 1 times 2 to the power of 6 times AX to the power of 1. If you simplify that, it gives us a coefficient of 448A. Next, we go hunting for the X squared term. We set R equals 2. That gives us 7 choose 2 times 2 to the power of 5 times AX squared. Simplify that, and you get a coefficient of 672A squared. Now here's the kicker. The prompt specifically told us these two coefficients are equal. So we just set 448A equal to 672A squared. From there, it's just basic algebra. The A cancels out on one side, and we find that our constant A equals 448 divided by 672, which beautifully simplifies right down to 2/3. By combining that cool vertical formula layout with our strategic coefficient hunting, you now have the exact toolkit you need to confidently dismantle literally any binomial challenge the exam throws at you. You genuinely no longer have to dread these questions. You can just hunt down the answers with total precision. So the next time you sit down with a past paper and see a crazy binomial bracket raised to the power of 15, the only question you really need to ask yourself is, what exactly am I hunting for today? And more importantly, what other impossible math problems out there are actually just simple patterns waiting to be decoded?